Rationalising the denominator. It's extension on how to do surds. You need to know what a surd is. I need to work with this. Right, let's do a nice question. A half. We'll still be used to a half. Now, what I want you to do is I want you to draw a shape that represents a half. And I'll be honest with you, all of you should do this. Yeah, I know it's not a perfect circle. Chop it in half. You're shading half of it. Yeah. Now this is something I can deal with. Yeah, I can deal with the concept of a half. I can physically, my brain allows me to do it. What about 1 over the square root of 2? Now that throws me. Now I can draw a circle, but then if I want to split it up, how can I split up something into the square root of 2? It ruins me. And the reason why I may find it really hard is that my denominator, the square root of 2, is just such a difficult concept. So it'd be nice if I could express this fraction in a different way where I don't have any surds on my denominator. So what I do in this instance is I times it by a different fraction. And this fraction is going to be the square root of 2 over the square root of 2. Because this actually is 1. And we can times the number by 1 and it definitely will be the same one. Let's do the numerators first. 1 times the square root of 2 is just the square root of 2. A square root of 2 times the square root of 2 is actually 2. Now, 1 over the square root of 2 and the square root of 2 over 2 are exactly the same. There's no differences. But if I ask you to represent the square root of 2 over 2, even though it's difficult, I find this to be a lot easier. So I draw a circle and I halve it. Now the square root of 2 is actually approximately 1.41. So it's going to be a whole 1 and a 0.4, which is about 4/10, which is going to be like this. And that's roughly what a fraction, what square root of 2 over 2 is. So what we like to do, if we got any fractions whatsoever, we always like to get rid of any surds that are on the bottom. And we like to make them rationalising. And this is what we call rationalising the denominator. So let's go to the next one. 5 square root of 2. Now, again, it's got a denominator which is irrational. So I'm going to times it by the square root of 2 over the square root of 2. Because, again, that equals to 1. Let's multiply it. 5 times the square root of 2 is just 5 square root of 2. Nothing complicated going on them. And square root of 2 times square root of 2 is 2. See if it can be cancelled down. It can't. Done. Okay. And again, these two are exactly the same. It's just 5 square root of 2 over 2. It's just an easier concept to deal with. Okay. 4 root of 5. We just times it by the square root of 5 over the square root of 5. Now we multiply. 4 times 5 is 4 root 5, sorry. And the root 5 over root 5 is just 5. Done. There's nothing else I can do because I can't cancel down 4/5. Okay. Work your way through. Yeah. Just please always check your answer, see if it can be cancelled down. Now, if you've got a calculator, your calculator will naturally rationalise the denominator. So if you want to just do this to f, okay, work it out. I'm not going to show the answers, but if you do 1 over the square root of 11, it will naturally rationalise it for you. Go. Brackets revision. I'm going to quickly do that. X times x is x squared. And then you do x times 4, which is plus 4x. And then you do 3 times x, which is plus 3x. And then 3 times 4, which is 12. Normally your two middle ones can add together. 4 plus 3 is 4, 5, 6, 7, which is 7x plus 12. Okay, should be nice and easy for you to do. I actually want you to investigate. Okay. And you've got two investigations on it. One on the left is easy, the one on the right is hard. So what I want you to do is I want to do x plus a and x minus a. And I want you to change the values of a. So first of all, make a1, then make a2, then a3. Expand it and see if you know a pattern. And when you notice a pattern, hopefully if I said x plus 10 and x minus 10, straight away you should be able to give me an answer. If you want a harder version, ax plus b and ax minus b, which is on your right here, I want you to substitute in a is 1, a is 2, a is 3, and then b is 1, b is 2, and b is 3. Expand it, see if you notice a pattern. And it's a very important pattern, this is maths. Pause the video. Now, if you're doing this one here, what you should notice is if I did a plus 7 and then so it's x minus 7, and this is just going to be x squared minus 49. And the easiest one is it's going to be your first digit squared, a minus, and a minus is important, and then your second digit squared. And it's only true when that sign's flipped. Okay? So if I do the harder version, the rules are exactly the same. So let's say I did 5x plus 4. And then 5x minus 4. All I have to do is square the first number, which I know is going to be 25x squared. add a minus, and then square the second number, which is going to be 16. And it's the difference of two squares. It's just really nice. And the reason is my two middle terms will cancel out. So if I've got something messy and I want to get rid of them, which will normally arrive in my middle terms, I do this and it will just make them disappear, which is nice and lovely. Okay. So let's do this one. And of course it's the difference of two squares. I'm going to do it a long way, but again you don't have to. X times x is x squared. X times negative square root 2 is negative square root 2x. Square root 2 times x is positive square root 2x. You can write x square root 2, it makes no difference. Square root 2 times square root 2 is minus 2. My two middle terms cancel out because there's a positive and a minus. So I've got x squared minus 2. My surds have disappeared from that equation, which is interesting. If you need more practice, yeah, you've got these questions here, but these were in the previous lesson, and again, this should be done for you. So here's your answers if you need them, but I'm not going to spend a lot of time on this. Now this one here, it's harder, but we need to rationalise this. And we've got to think, is there a way that we can multiply this by a fraction, yeah, which has the same numerator and denominator, that will get rid of my surds? Now if I do it like 4 plus square root of 2, what you'll find is when you multiply these together, so I've got 4 times 4 is 16, and I've got 4 times root 2 is 4 root 2, this 4 root 2 will not disappear. So that is not the way we do it. And actually what we do is we change this sign to a minus. So we get difference of two squares. And my denominator is, let's do the top, 4 minus root 2. 4 times 4 is 16. Yeah. 4 times negative root 2 is negative 4 root 2. And I've got positive root 2 times 4, which now makes it a positive 4 root 2. And a root 2 times root 2 is just a negative 2. My two middle terms will cancel out because I've got a positive and a negative. And I've got 16 minus 2, which is 14. So my denominator is 14. And let's do my numerator. I'm going to treat these out as brackets. It's 1, so it's 1 times 4 is 4. And then 1 times negative root 2 is just negative root 2. And that's this one rationalised. So this one here, I need to think of what fraction can I do that will get rid of the denominator. I keep the first digit the same. I'll do a minus, and I'll keep the second number the same. It's got to be the same on the top because this fraction's got equal to 1. Now I'm putting brackets around it just because it makes the maths a little bit easier. So let's deal with the numerator first. 1 times 2 is 2. 1 times negative root 3 is negative root 3. Let's do the denominator. 2 times 2 is 4. Now I don't care about the middle terms because they'll cancel out. But if you did care about the middle terms, it actually is going to be a positive 2 root 3 and a negative 2 root 3, which actually just equals nothing. Root 3 times negative root 3 is minus 3. And that's really because root 3 times root 3 is root 9, which cancels down to 3. My numerator stays as 2 minus root 3. And my denominator is 4 minus 3, which is 1. Any number over 1 is just the same, because if we divide it by 1, nothing happens. So my answer is 2 minus root 3. Now if you type this into your calculator, and just press equals, your calculator will naturally sort it out for you, and you'll get 2 minus root 3, if your calculator is decent. You've got to ask yourself, what can I times this by? So I'll keep the first number the same, flip the sign, and keep the second one the same. So if it started off being a minus, I'll change it to a plus, but it's not. My numerator's got to be the same as my denominator, because this one's got equal to 1. Let's expand the numerator first. So I'm going to treat these as brackets. 3 times root 5 is 3 root 5. And 3 times minus 9 is minus 27. Okay, root 5 times root 5 is just 5. Don't care about middle terms, but you can do it if you want. In this case, it'll be positive 9 root 5 and negative 9 root 5, which will be equal to 0. 9 times 9 is 81. Okay, so my numerator is 3 root 5 minus 27. And 5 minus 81. Okay, be careful with that, because 5 minus 81 is minus 76. Okay, now again, we don't actually like the minuses on the denominator, so I'm actually going to flip around all the sides. So 3 minus 3 root 5 plus 27. All of this over 76. And just see if this can be cancelled down. I know 3 is in 3 root 5, and I know 3 is in 27. So see if 3 is in 76, which is not, so here's your answer. Okay, here's some questions. Work your way through them. Top's a little bit harder than the ones on the, easier than the ones on the bottom, because the bottom's got 2 square roots. And again, I'm not going to show the answers, because if you just type this into your calculator, and your calculator is mildly decent on the ones you should have for GCSE, it will show the answer. Okay, hope you enjoyed that lesson.